Thought for 9s in just 12 days, an interstellar giant weighing an estimated 33 billion tons, known as Atlas, will hurtle past our sun at a blistering speed, 80 times faster than a bullet. But what if this isn't just a random cosmic rock? What if its eerily precise path hints at something engineered, designed to slow down and linger in our solar system? As it vanishes behind the sun, we'll be left in the dark wondering what emerges on the other side. Could this be nature's fluke, or a visitor with a purpose? Stick around as we unravel the mysteries that could rewrite everything we know about the universe, and why you won't want to look away until the very end. Let's start with the basics. What exactly is Atlas, and why is it causing such a stir? Discovered on July 1st, 2025, by astronomers in Chile, this object is barreling toward our sun at over 200,000 kilometers per hour, far too fast to be trapped by its gravity under normal circumstances. It's the third confirmed interstellar visitor we've ever spotted, unbound to our star like a drifter from another galaxy. But unlike the previous two, Oumuamua and Borisov, which slice through at steep angles, Atlas is gliding almost flat along the plane where our planets orbit. Tilted just 5 degrees from the ecliptic, that invisible disk where Earth, Mars, and the rest spin like beads on a string, this alignment defies the odds. Why would a random comet from deep space line up so perfectly? How could it mimic the path of something familiar with our cosmic neighborhood? Imagine throwing darts at a spinning globe from every direction. Most would miss a specific street by miles. For interstellar objects, random arrivals should scatter across the sky, with only a tiny fraction hugging the ecliptic so closely. Orbital simulations by planetary scientists confirm this. The probability is minuscule, like hitting a bullseye blindfolded. Yet here comes Atlas, racing retrograde against the flow of our planets, but skimming the surface like it knows the rules. This isn't just odd. It opens doors to wild possibilities. If it's natural, fine, a statistical outlier. But if not, what if this path was chosen to maximize a dramatic maneuver at the sun's doorstep? When does this all unfold? Perihelion, the closest approach, hits on October 29, 2025, at 136 astronomical units, just inside Mars's orbit. It's like threading between two speeding cars on a highway. Normally, orbital mechanics dictate it'll slingshot out and vanish forever. But that precise alignment, it screams opportunity. Enter the Oberth effect, a physics trick named after Hermann Oberth in 1929. How does it work? Simply, a rocket burn packs way more punch when you're already zooming fast near a massive body like the sun. The energy boost squares with your speed. Push a parked car and it barely moves. Shove one at highway velocity and it flies. For Atlas, screaming in at 68 kilometers per second, twice the speed of our fastest spacecraft, this is prime time. To get captured into a solar orbit, it'd need to shed about 20 kilometers per second via a retrograde burn, firing engines backward right at perihelion. Why there? The sun's gravity amplifies the effect, turning a modest thrust into a game changer. Natural comets might outgas jets of vapor, nudging them by mere meters per second, like a gentle breeze. But 20 kilometers s? That's a hurricane. It'd require fuel mass rivaling the object itself, pushing the limits of known tech. Yet, if engineered, this path makes it feasible. The question lingers, is Atlas poised to break and stay? And if it does, what emerges? A harmless rock or something probing our system? But here's where curiosity spikes. We won't see it happen. From mid-October to early November 2025, Atlas slips behind the sun from Earth's view. A blackout window from October 22nd to November 7th. Why the blindness? Astronomical rules. No major telescope, ground-based or spacebound, points within 30-85 degrees of the sun. It's like staring into a spotlight. Hardware safeguards kick in to protect optics. Hubble, James Webb, even TESS, all off-limits. Solar probes like Parker and Orbiter are laser-focused on the sun itself, not faint comets. Mars orbiters tried snapshots during Atlas's early October flyby, but the object was 50,000 times dimmer than their usual targets. ESA's ExoMars Trace Gas Orbiter grabbed blurry frames, dismissed as noise, no clear detections. So during this critical phase, when any maneuver could occur, we're in the dark. What if Atlas fragments, deploys, or alters course unobserved? When it reappears in November's dawn skies, astronomers will scramble for clues. A sudden velocity drop, organized debris trails, or spectral shifts. Imagine piecing together a thriller's plot. After missing the climax, that's our reality. The stakes? If natural, it's a rare comet. If intentional, it could mean we're not alone, with implications rippling through science and society. Adding to the intrigue, the mass mystery. Brightness readings peg Atlas at 33 billion tons, heavier than many comets. But during its October 3rd Mars flyby, just 29 million kilometers away, there was nothing. No gravitational tug on Mars or orbiters. Deep space network tracking? Zilch above noise. In 2014, a smaller comet's Mars pass left detectable ripples. Here, silence, like a massive truck gliding by without shaking the ground. How is that possible? Overestimated mass. Maybe it's unusually reflective or dusty, inflating its glow. Or porous, like a cosmic sponge. Rotation data shows it spinning faster than a solid rock of that size should, hinting at a hollow shell. A balloon masquerading as a boulder. Who uncovered this? Planetary dynamicists poring over navigation data from NASA's Mars Reconnaissance Orbiter and ESA's teams. No perturbations mean negligible gravity, pointing to emptiness inside. If hollow, why? Nature could craft porous bodies, but a shell invites speculation, designed to break open at perihelion, releasing. What? Probes? Sensors? The chemistry adds layers. In mid-September, spectroscopists spotted a 180,000-kilometer coma, a gas dust envelope dominated by hydrogen cyanide, venting 2 kilograms per second. Traces of water and carbon monoxide fit comet norms, like a familiar recipe with tweaks. This baseline will flag any post-perihelion weirdness. Sudden composition shifts or asymmetric jets could scream anomaly. Now, let's dive deeper into the hollow shell idea. How might it play out? At perihelion, intense heat and gravity could fracture a fragile body naturally, random debris scattering like confetti. But what if it's engineered? Picture a deliberate unfold, shell cracking to deploy smaller units, each on precise paths. Evidence? Post-blackout. Look for non-random trails, fragments accelerating oddly, clustering or forming patterns. Straight lines amid chaos, that's a red flag. Scientists like Avi Loeb through the Galileo project are gearing up, track fragments, measure velocities, compare to comet models. Random drift, natural, orderly motion, world shaking. Those lost Mars images fuel the suspense. ExoMars camera, meant for Martian dirt, strained for 5-second exposures of a speck in space. Results? Pixel soup, static where Atlas should be. ESA analysts flagged it as noise, data delayed by downlink priorities and calibrations, slated for late November release. By then, perihelion's long past. What if those blurry dots hide a shape, a structure? Too late for real-time action, like replaying a game after the buzzer. What if capture happens? A permanent interstellar resident would be a scientific goldmine, extrasolar material to study forever. But for defense folks, contingency memos at NASA and Space Force model escalations. Surveillance ramps up if velocity sheds suspiciously. No public alerts yet, but the whispers suggest preparedness. A headline of "Alien probe deploys" could spark global ripples, panic, wonder, markets tumbling. Why prepare? Because extraordinary claims need evidence, but the setup demands vigilance. To sort fact from fiction, here's your checklist. Watch for velocity steps in exit data. Beyond, outgassing. Scan for organized debris, not spray. Cross-check UAP reports timed to perihelion. Data floods in November-December from NASA, ESA, CNSA, Galileo archives. Optics, radar, polarimetry, citizen occultations. Falsifiability rules. If paths align naturally, no anomalies, it's a comet. But if data defies, we're in uncharted territory. Verifiable facts anchor us. October 29th, perihelion at 136 AU. 5-degree ecliptic tilt, rare per models. No Mars gravity effect despite brightness estimated mass. Blackout gaps per schedules. No classified alerts released. Post-perihelion velocity and debris in late November will tell, porous comet or engineered marvel. As the clock ticks, the silence builds tension. In weeks, we'll know if Atlas is history's weirdest comet, or a beacon proving we're not alone. What secrets hide in that blackout? How will the universe surprise us next? Don't stop now. The reveal could change everything. The cosmos is watching back. Stay tuned for the truth that emerges from the shadows. Atlas will either vanish as another cosmic oddity or return bearing answers that rewrite our place in the universe. Between the sun's glare and November's reveal lies a blackout full of possibility. Fragmented clues, strange trajectories, or the silence of a natural comet. We'll be watching every data point, every spectrum and every orbit. If you want real-time analysis as results arrive, subscribe and hit the bell. Share your theories below, skeptic, hopeful, or stunned. Because when Atlas reappears, the sky may tell us whether we're alone or joined by something far stranger. Stay curious. The universe keeps surprising.